Hi guys, I'm Duncan from 21417A Robotics, and I'm here to do an intake explanation on speed. So our intake is basically composed of 4 main rollers, 3 that are only on the intake and 1 that doubles as our indexer. So starting with the first roller, so this roller we had spinning at 750 RPM. So I know that sounds like a weird ratio and unusual, and we basically achieved that by having custom Lexan sprockets on this powered roller, which is the third roller. And that just gave us the ability to make this faster to help intake disc better. And as you can see, it gets them in pretty well. So the next roller here is on the bottom. So this roller basically just mitigated the dead zone between these 2 rollers. It basically just transitions the disc from the first roller to the third roller. And that's just a chain running from the back of the robot down under everything. That's how we powered that. And then this third roller is the most important for spacing wise because it pushes the disc into the last roller, which is also the indexer. And the spacing on that's just really important for transitioning the disc. So as you can see, if I run one in here, it hits at the perfect angle to slide under the disc, and the indexer roller pulls it back. So to keep all the disc flat in the indexer and compressed in contact with that indexer wheel so it actually shoots, we have a floating 4-bar tensioner. So this tensioner is really important for transition because it keeps the disc flat so the other disc can come under it. And it's also really important to keep it in contact with that last wheel. Otherwise, the disc would not shoot as fast, nor would the transition be as clean. So after that, this last roller, basically it just sucks disc in when they come out of the second roller, pulls them under the second disc that's in there. And then when we spin it in reverse, it shoots the disc. We don't have our flywheel on right now. It would shoot the disc if it was on, but you can see that just spinning that reverse shoots the disc out. So I'm gonna move on to our roller mech, which is actually also part of our intake system. It's all powered off of this one motor that's geared to the third roller, and there's just a chain on the other side here that goes up, and there's a sprocket reduction ratio that just gives this roller mech more torque, and there's actually a double reduction ratio because there was too big a sprocket on here originally. But you can see that we have set it at the perfect height and angle where it spins the rollers really easily. And we can spin the rollers regardless of whether there's 3 discs in here or 2 discs. We haven't really encountered any issues with friction so far. And that's just because we had to put a lot of effort into getting the spacing correct on all the gears and sprockets and how everything meshes, just to reduce friction. And we've also used grease to lubricate everything, which is also a good way to reduce friction. One last thing I'd like to talk about. There's a lot of issues with picking up 4 discs sometimes. So we have a potentiometer that we hooked to our tensioner, and this essentially just we're able to use the value off of that to say whether we have 4 discs. So you can see that, if we put 4 discs in here, the potentiometer value would be much higher than a threshold we set. So we could basically just say spin reverse immediately and shoot that last disc out to get rid of it. Basically, that was a really good way of just mitigating that. And also for rapid fire shots and skills, we were able to just spin the intake until that was completely down. And that was a good way to break it out in great timing.